Bismillahirrahmanirrahim. So today, inshallah, we're going to start the chapter gravitation and gravity. Both the topic are familiar to you, right? Okay. So the first topic we have in this chapter is falling body. Any body you leave from a certain height, it will fall on the ground. Okay. So this falling body actually maintains or follows three laws that are given by Galileo. Okay, we know them as Galileo's falling body laws. Awesome. So first law that says starting from rest, all bodies falling freely from the same height traverse equal distance and equal interval of time. That means from the same height from the ground. Okay, if I leave two body, okay, they both will reach the ground at the same time. That means they will cover the equal distance in equal amount of time, okay, irrespective of their masses. Now this is something that goes against our normal sense, right? We know that if an object is heavy, that means the mass is higher, then what will happen? It will fall on the ground faster, right? It will reach the ground faster. And if we have a light object, that will reach the ground a little bit later, right? It will take more amount of time. But the thing that we forget, we are mentioning here falling freely. Freely means the only force that will be working on it or acting on it or being applied on this body that we can consider is gravity. Okay, no other force can act on it. Okay, but while we are doing the experiment on the earth, what happens? Air resistance is there, right? Okay, now every object does not have the same capability of overcoming the resistance of the air, right? Some objects which are higher or heavier, okay, of higher mass, they have the greater capability to overcome the air resistance, and that's why they fall on the ground or they reach the ground faster than the lighter object. But if you can somehow carry out the experiment in a place where the air is not there, no air resistance is there, okay, only the force of gravity is acting on two body, you will see that both the bodies are reaching at the same time, reaching the ground at the same time. Okay, that means they are falling together, they are covering equal amount of distance in equal amount of time. Okay, that's what it says. Second law, starting from rest. Okay, always for a falling body we are considering it is falling from rest. Okay, it was at rest, then we leave it, it is falling. So the velocity will be proportional to the time. Okay, that means after 1 second, if the velocity is 9.8, obviously the velocity will be 9.8 because acceleration due to gravity is there, right? The force that is acting is gravity. The acceleration that will be caused due to this force will be acceleration due to gravity as we know it, and the value of it is 9.8 meter per second square. That means every second the velocity will be increasing by 9.8. That means as soon as we leave it, the initial velocity when time t is equal to 0, the velocity will be 0. But after 1 second, when time t is equal to 1 second, the velocity will increase from 0 to 9.8. The increase is 9.8. Then after 2 seconds, it will be 19.6. That is double of 9.8. Okay. So you can see as the time got doubled from 1 second to 2 seconds, the velocity also got doubled. Then when it is 3 seconds, it will be 3 into 9.8. Okay, and when it is 4 seconds, it will be 4 into 9.8. So the relation is proportional. Okay, the time, how much the time is becoming, how much times the time is becoming, that time the velocity will also become. Okay, if it is doubled, it will also be doubled. So directly proportional relationship. Okay, the third law. Acha, before I move to the third law, I need to actually establish an equation for this. See, v is proportional to t. That's what we got to know. Okay, now if I want to put an equation, I need to introduce a constant. Let us say that is k. So t, if I change the side, v by t should be equal to k. Now what does this mean? For t1, as the time is v1, at t1 time the velocity is v1, at t2 time the velocity is v2, at t3 time the velocity is v3. The ratio of them will be a constant. See, the ratio of velocity and time is constant. That means the ratio of velocity and time Okay, for corresponding time and velocity, the ratio is going to remain constant, and that will be equal to the constant k. Okay. Acha. So this is the equation that we may put into use while solving numerical examples. Okay, v1 by t1 equal to v2 by t2. Acha. Then the third law relates the covered distance with time. It says that starting from rest, okay, always remember, starting from rest, a body covers, the distance covered by the body is directly proportional to the square of the time. Okay, square of the time. Now from here, very important MCQ that you will face in the exam. Okay, they will ask you, if the time becomes double, the distance covered will become, anybody can say?
4 times.
4 times. Square is there. Time becomes double, so the height will become square of it. That is 4 times. Okay. So if it becomes 3 times, then 3 square height will become 9 times. Now sometimes the question might be asked in the reverse direction. They will tell you that if the covered distance becomes 9 times, then the time will become root over of 9, right? If you are going in the opposite direction, we need to do root over. Okay, if you are coming from this direction to this direction, from this point to that point, then you have to do square. But if you are moving from here to here, then you have to do root over. Okay, so always remember, if the time is given, you are here, then you need to go here. So if you are moving in this direction, you need to do a square. But if the information is given regarding the covered distance, you are here, you need to move from here to here. So you need to do root over. Okay, so remember this one, please. Achha, from here, we can develop a similar type of equation that we did for second law. That is, h is proportional to t square. So h will be equal to kt square. H by t square is equal to k. So from here we can write h1 by t1 is equal to h2 by t2 is equal to h3 by t3. Okay. For corresponding, square will be there. T1 square, t2 square, t3 square. Okay. It will be equal to that constant. Okay. So the ratio of the distance covered to the square of the time taken to cover the distance will always remain constant. Okay, this ratio will always remain constant. This equation also we may use in numerical problem. Anybody have any doubt understanding this equation?
No.
Nobody. Okay, after that you can see that we have a practical. Inshallah, we will be doing it once the school reopens. Inshallah. Then the next topic we have 345 page. At the bottom of the page, the topic starts, that is gravitation. We know that the force, every object in this universe, okay, attracts each other, every object. Okay, while we're talking about gravitation, there is no repulsion, only attraction. Repulsion occurs when, in case of magnet, okay, same pole, they are brought closer to each other, then repulsion will occur. Or positively charged body brought closer to each other, they will repel each other. But in case of gravitation, there is no repulsion. Every object in this universe attracts each other. Okay, so this force of attraction between any two body in this universe is called gravitation. Okay, now Newton's law of gravitation. Okay, this is something that you have already studied, I feel, and this is quite similar to Coulomb's law. Do you remember Coulomb's law? So Newton's law says, it tries to find out the magnitude of the force that acts along it and the direction. Whenever we are saying or talking about force, okay, we need to mention both magnitude and we need to talk about the direction also, because this is a vector quantity. Okay, so Newton's law of gravitation does that. It says, it gives an idea how the force is going to be between any two bodies. We know that the force of attraction is there, but how much is the force, we want to know. Okay, now it depends on couple of factors. The force between any two body in the universe is directly proportional to the product of their masses. Okay, if we have two body, m1 and m2, Okay, so it is the force that will be attracting. Okay, see, they will be attracting each other. So the force will be proportional to the product of their masses. Okay, if one of the masses get doubled, then what will happen? The force will get doubled. But don't get puzzled over here. Okay, there is a very important thing. If both the masses get doubled, then force will become
4. I
4
mean,
times.
4.
This is very important. Okay, we always say that the force is directly proportional to the product of their masses. So when I say that if both the masses become double, then they think as it is directly proportional, the force is also supposed to become double, right? But the thing is, I said that directly proportional to the product of their masses. If this product is multiplied by 2, then the force will also be multiplied by 2. But this product contains two separate quantity, right? If each of them become double, then the product actually becomes 4 times. So if the product becomes 4 times, then the force will also become 4 times. This is very easy, important to understand. Easy also, right? Okay, you understand if this become 3 times, this become 3 times, then 3 3 is 9 times. The product will become 9 times and the force will also become 9 times. Be very careful, okay? Acha. And inversely proportional to the square of the distance between them. Let us say the distance between them is r. Okay, so the force will be inversely proportional. Inverse means opposite relation. If the distance increases, we know that as the body will move further and further, the attraction force between them will be lower and lower, right? Okay, so it goes like this. So now here also I want to let you know that what type of MCQ might come. They will ask you if the distance get tripled, then force will become how many times?
1 by 9 times.
Very good. 1 by 9 time. Okay, the distance has become 3 times. So you need to know that 1 by 3 square times the force will become, right? So that is 1 by 9. Good, very good. That means you know. So in the reverse direction, if they ask you if the force has become 1 by 9 times, then the distance has become 3 times. Okay, I hope you can solve it now. Okay, so we have already got idea about how the magnitude is going to be, or on which factor it depends, and now we need to talk about the direction. Okay, in which direction the force is going to act. It will act along the line, perpendicular line joining the two body. Now if I tell you draw a line segment that joins both the body, so definitely you will draw this line. Nobody will draw a line like this, right? They will go up and then nobody will join like this, right? So whenever we are talking about joining two body, we are talking about joining them perpendicularly, the perpendicular distance between them, which is also can be mentioned as the shortest distance between them. Okay, so along this line the force will be acting. The force exerted by this body on this one will be along this line in this direction, and the force exerted by this one on that body will be along this one in this direction. Okay, acha. So we also got to know, and now I will read out the law statement. Just check whether you understood or not. Every particle in this universe attracts each other. See, they did not say that they apply some force on each other, because when you say only force, it might mean attraction and repulsion. Okay, attraction or repulsion. But here they directly mentioned it is attraction only. So that is why every particle in the universe attracts each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And the force acts along the straight line joining the bodies. Understood? Okay.
Yes.
Okay. So if I combine, I will get this. Okay. If I want to replace the proportional sign with an equal sign, I must introduce a constant. and that constant is called gravitational constant. Gravitational constant, and the value of it is known as 6.673 into 10 to the power minus 11, and the unit I never memorize, I just find it out from this equation. See, if I ask you to find out an expression for G, what you will do? R square, you will multiply this with F. So F is Newton and R is meter. So Newton meter square. This M1, M2 will be in the denominator if you change the sign. So kg into kg, it will be kg inverse 2. Okay. So I have seen many times ask in the MCQ that they ask which one of the following is the value of G, gravitational constant. So what they do is 10 to the 1, not minus 2, 10 to the minus 11. Sorry. Maybe আমি মুখে 11 বলছি but লিখে ফেলছি 2, তাই না? Okay. 6.673 into 10 to the minus 11 Newton meter square per kg square. Okay. So this is the value. So what will they will do? They will keep the value same, but they will bring changes in the unit. Okay. So before you mark the correct answer, check whether both the value and the unit are correct or not. Okay. Please be careful. Okay. Acha. Then now the significance of G number question for 2 mark. Okay, in B they might ask you what is the significance of G. We can easily find it out. See, if F is 1 Newton, M1 is 1 kg, M2 is also 1 kg, and R is equal to 1 meter. Everything is 1. Okay, so let us not consider the force as 1 Newton. Just let's keep it this way, that masses are 1 kg and the distance between them is 1. Then this equation will become F equal to G, right? Correct? So can I say that gravitational constant is the force between two bodies of unit masses kept 1 meter apart? Can I say it?
Yes.
Right, I will tell you again. If you understand, you don't have to memorize, just try to understand what I'm saying. Okay, here I considered both the bodies of unit mass and the distance between them is unit distance. Okay, so if I put all these values over here, then all this part will become 1, right? So G will be equal to F. So I can say that gravitational constant is actually the force between two bodies of unit masses kept 1 meter apart. Okay, see, the distance is 1 meter. So try to understand these things in this way so that you don't have to memorize anything. Rather, you can write, from your realization. Acha, the next topic we have is universality of G. Gravitational constant G is a universal constant. Kindly go through this paragraph. I will be back within 1 minute, inshallah. Okay, so let us talk about the word universality first. What do we mean by universality? Let us say something which can be applied for everything and everyone, for all the objects that are in the universe. Okay, then that thing is called universal because it is applicable for everything. Now there some things are there which are not applicable for all. Maybe there are some laws, okay, which are not applicable under certain condition, or it is applicable only under certain circumstances. Okay, so those are not actually universal. Something that can be applied everywhere, okay, that is called something universal. Now the value of G, it is called universal. Why it is called universal? Because it actually does not depend on what medium the bodies are, right? First of all, it does not depend on in what medium the bodies are. You keep the body in air medium, vacuum, water, the value of G will never change. The value of G will never change. It will be this value no matter where you keep those body, in which medium you keep those body, first of all. Second, it does not matter what material is the body made of. Sometimes we see that, let us talk about the melting point. The melting point of iron is not as same as the melting point of ice. Okay, so as the material is changing, the melting point is changing, but the value of G will not change. It is same for iron, it is same for ice, it is same for all the objects that are there in the universe. Okay, it also doesn't depend on any other characteristic. Okay, it does not depend on any other characteristic like what is the length, what is the area, what is the volume. No, it doesn't depend on that. Okay, acha. So we know that the nature or the material of the object is not a factor that decides how the value of G is going to be. So G, this value is applicable for all the materials in the world and all the mediums in the world, right? So that is why we call it universal. That is the universality of the value of G. You understood?
Yes.
Okay. Then let us move to our next topic, which is new to you. Whatever we studied till now, you already studied in grade 10 itself, right? Acha, I actually forgot. In grade 10, do you study Newton's law of gravitation? No?
Yes, in fourth chapter.
In fourth chapter, right. I actually forgot. Okay, so Kepler's law of planetary motion. We know that planets around the sun, they are in continuous motion, right? Okay, now this was not the idea always. I mean, this was the phenomenon that was taking place always, but people didn't know about it. Okay, previously there was a time when people used to think that Earth is the center of the universe and every other object is revolving around it. Okay, and this idea was actually given by Ptolemy. Okay, he actually gathered all the observations of the Greek astronomers, okay, and he represented gathering all of them as a theory, okay, which says that actually Earth is the center and all other objects, revolve around it. Now, many of the observations were there which actually couldn't be explained by considering Earth as the center, okay, but still people accepted it. Can anybody say why people accepted it, even though there are several observation which cannot be explained considering Earth as the center? Then why people accepted it?
তো মেবি দেখতো যে চাঁদও ঘুরতেছে, সূর্যও ঘুরতেছে,
না,
এই
সেটা তো
জন্য।
ঠিক আছে, ওই অবজারভেশন গুলো দেখে দেওয়া হয়েছে, বাট আরো কিছু অবজারভেশন ছিল যেগুলা মানে আর্থকে যদি তুমি সেন্টার ধরে অন্য সবকিছু আর্থে চারপাশে ঘুরতেছে এরকম যদি ধরো, তাহলে ওই অবজারভেশন গুলাকে ব্যাখ্যা করা যায় না। কিছু হেভেনলি বডিজ আছে যেগুলা মানে এক্সপ্লেইন করা যায় না, তারপরও পিপল এটা একসেপ্ট করছিল কেন?
মানুষ এত থিঙ্ক করতো না।
মানুষ এত থিঙ্ক করতো না, তার থেকেও বেশি ইট ইউজ টু গিভ দেম আ সেন্স অফ সুপিরিয়রিটি। ওদেরকে মানে মানুষজন এটা থিঙ্ক করতে পছন্দ করতো, ও আমরা সেন্টারে, বাকি সবাই আমাদের চারপাশে ঘুরতেছে, ওয়াও। ঠিক আছে, কি বলতে বুঝতে পারছো? It was the case at that time, but now we know that anything that you say which gives people the sense of superiority will not be accepted. You have to prove it through mathematical analysis or through some experiment or some process like that, right? Scientifically you have to prove it. But that time it was not like that. The scholars were the only people who were knowledgeable, and the other people just used to believe whatever they said. Okay, they never used to think about it much, and this was something that gave them to think that they are superior than other creatures in other planets. Okay, so that is why they accepted it very easily. Okay, even though there are so many complexities in this theory. Okay, now in this theory actually prevailed up to 15th century. Okay, up to 15th century people used to think this way, but in 16th century Copernicus founded something very interesting. He said that if we consider the center of the universe, the sun, okay, if we consider the sun as the center of universe rather than considering Earth, then all the explanations, all the observations can be explained in a proper way. Okay, so he said that, see, it is written in your book. In 16th century Copernicus said if sun is considered the fixed center of the universe, then a simple explanation of the heavenly bodies can be given. According to the theory of Copernicus, Earth is a planet which revolves around the sun just like other planet. Okay, and the same type of motion are also present in other planets like the Earth, right? Now the conflict, you see there is a clear conflict. One says, one theory, the previous theory used to say that the earth is center. Now the Copernicus theory that he gave, it says that the sun is the center of the universe. So there is a conflict, right? So that made actually other people interested to gather more information on this one. Then they said, okay, there are two theory now. Okay, at first obviously people didn't actually wanted to accept the Copernicus theory because you know, they are losing their superiority, right? So they didn't want to accept it, right? But later they became interested and they became you know, they started gathering information on this. Okay, so Tycho Brahe was a scientist who collected various information, and his colleague Johann Kepler. Okay, the topic is Kepler's law of planetary motion. So we came to Kepler now. So Kepler actually used this gathered information by Tycho Brahe, and then you know, found some regularity, okay, in the motion of the planets, and those regularity has been put into words using three law. He gave three law about the motion of the planets. Okay, so what are those laws? The first law: each planet moves in elliptical orbit with the sun at one focus. Now ellipse is something that you are not familiar with yet. Okay, when you will go to grade 12, inshallah. Actually, I forgot, grade 12 or grade 11 book, you have this chapter conic. In your book, textbook, do you have a chapter called conic? Higher math? জানো না মনে হয়, ওকে, বই উল্টা পাল্টে দেখা হয়নি। ছোটবেলায় আসলে নতুন বই আসলে অনেক এক্সাইটমেন্ট কাজ করতো। আমার এখনো মনে আছে ছোটবেলায় যখন আমরা নতুন বই পাইতাম, স্কুলে ক্লাস এখনো সেভাবে শুরু হয়নি, আমি বাংলা বইয়ের গল্প সবগুলো পড়তাম, ভালো লাগতো। ইংলিশ বইয়ের গল্প, বাট হায়ার ম্যাথের বই কেউ উল্টাই দেখে, তাই না? যদি বুঝো তাহলে অনেক মজা আছে কিন্তু। আচ্ছা, তো এখানে what we considered till now, হ্যাঁ,
9 মানে 11 এর বুকে নাই,
চ্যাপ্টারটা নাই কনিক।
11 এর বুকে নাই, তাহলে 12 এর বুকে মোস্ট প্রবাবলি কনিক নামে একটা চ্যাপ্টার আছে। সেখানে তোমরা পড়বা সার্কেলের তিনটে শেপের ব্যাপারে। একটা হচ্ছে ইলিপস, একটা হচ্ছে হাইপারবোলা, আর একটা হচ্ছে প্যারাবোলা। ও আমি অলরেডি এটা বলছি মনে হয় তোমাদেরকে, না? বিকজ আমরা অলরেডি পড়ে আসছি বাংলা, এটাকে
গ্রেড 10 এ বলছিলেন।
কি বলে, প্রজেক্টর।
ওই যে যখন গ্রাফ এসব করাচ্ছিলেন তখন।
হ্যাঁ, রাইট, ওই প্রজেক্টর যখন পড়াচ্ছিলাম তখন বলছিলাম, তাই না? সো এখানে জিনিসটা হচ্ছে কি, যে তোমরা ইলিপস জিনিসটা হচ্ছে এরকম। এটাকে আমাদের এক টিচার ছিল, উনি বলতে পছন্দ করতে, এটা চমচম মিষ্টির মতো দেখতে, টাঙ্গা এটা চমচম মিষ্টি, which is actually true. Okay, so till now what we know, what we used to think, that the earth moves in a circular path around the sun, right? If this is the sun, okay, the earth moves around it in a circular path, keeping the same radius, right? But this is not actually true. The earth moves around the sun in an elliptical path. Now when you study ellipse, you will get to know that there are two focus. One focus is here, another focus is here. Okay, two focuses are there. Focuses, no, foci, in the plural, focuser plural hoche foci, two foci. Okay, f and f prime, two foci. Okay, are there. So when the earth moves in an elliptical path like this, now you might ask, sir, where is the sun? The sun is at one of the foci. Let us consider for now that the sun is at this foci. Okay, so the sun is at one foci and one focus, sorry, and the earth and all other planets actually move around it in an elliptical path. Okay, acha. So this is the first law. Each planet moves in an elliptical orbit with the sun at one focus. See, যে কোনো একটা ফোকাসে সানকে রেখে এবার এটা ঘুরতে থাকে। Then the second law says, acha, before I actually discuss about the second law, I want to tell you something very interesting. As the earth moves around the sun, the velocity is not actually same every time. Okay, when the earth comes closer to the sun, see, when it is passing through this area, okay, through this path, through this portion of its path, the velocity is higher. Okay, so what happens is the velocity is very high, he passes this one quickly, and then as he goes away, the velocity is slower, slower, slower. Again fast, then slow, slow, slow. Again fast, slow, slow. So the thing is like this, okay? So this path he actually covers in a very short amount of time, and this path he takes longer amount of time to cover, okay? Now let us talk about the second law, the law of area, okay? Each planet moves in such a way, okay, that the line joining the sun and the planet sweeps out equal area in equal time. What does this mean? Let us say the sun was here at some point, okay, and sorry, the sun was here initially at some point. The line joining the sun and the planet is this. Let us say after 5 days the earth has come here, so the line joining the earth and sun is here, right? So in this 5 day time, what is the area that has been swept by the line? Okay, see, they are talking about that the line joining the sun and the planet sweeps out equal area. So this is the area that he has swept in this 5 day time. Okay, now let us again consider that the sun was here at some point, and after 5 days the sun came here. We know that here the velocity will be slow, right? The sun, our planet will be moving in a lower velocity, right? Here it will be covering more amount of distance because the velocity is higher, but when it is away it will cover less amount of distance. So if I join this line now, what is the area that is covered by this? Let us say this is also 5 day time, okay? The difference of these two positions is 5 day. So according to this law, we can say that the area that we have here should be equal to area we have here, okay? So in equal amount of time, that this line sweeps out equal amount of area. Understood?
Yes.
Okay, you will see that if this is the line, and as time is passing, this will sweep out some area, okay? And when it is here also, as the time is passing, it will be sweeping out some area. So this area, if the time difference is equal, doesn't matter wherever you take it, it will cover the same amount of area. Okay, now this is actually explained in the explanation of the law, second law. Okay, I will just explain it with my own words. You may go through the explanation at home, okay? And find, just check whether you understand it or not, and if the things are similar with what I said, okay? Acha. Then third law. Third law is of law of time period. We already know what time period is, right? Let us say the Earth started moving from here and it covered a full rotation and came back here. That is called time period, right? Now, can anybody say what is the time period for Earth?
365 days.
Yes, 365 days. Very good. Okay, 365 days. Actually, it is not the accurate, we already know that it actually takes a little
64
bit.
days,
3
64 days 22 নাকি 3 hours না?
না, এরকম এটা আমি যতটুকু জানি ওই যে কি যেন 20
অনেক ক্লোজ 20 ইসে
আমি
65
ভুলে
এ।
গেছি, এটা 4 ঘন্টা বেশি সময় নেয়, 4 ঘন্টা 48 মিনিট 47 সেকেন্ড, খুব সম্ভবত এটা। ঠিক আছে, আমরা যখন এই যে রাত্রে 12টায় নিউ ইয়ার সেলিব্রেট করি না, এটা আসলে আমি দেখলে ভুলে গেছি, সো এটা আসলে বলাটা ঠিক হবে না। ওকে, তোমরা এটা একটু দেখে নিও যে এক্স্যাক্টলি কতক্ষণ লাগে সানের চারপাশে ঘুরে আসতে। ঠিক আছে, ইট ইজ নট এক্স্যাক্টলি 365 days. Okay, anyway, for now we can consider 365 days. So these laws are not actually only for Earth, this is for all the planet. Okay, so that is why they have taken the time period which is not actually same for all the planet. Okay, for Earth it might be 365, for other it might be different. Like for Mercury, the closest planet to the sun, takes only 88 days to complete one rotation. তো ওদের ওখানে এক বছর, 88 days এক বছর হয়ে যায়। আচ্ছা ঠিক আছে, যাই হোক। So the square of the time period, okay, the square of the time period. You know that we represent any time other than time period by small t, but time period we represent by capital T. So the square of time period of any planet around the sun is proportional to the cube of, okay, cube of semi-major axis of the orbit. Semi-major axis that we consider A. Now we want to know what is semi-major axis, right? Let us see what is semi-major axis. So as I told you, it is an elliptical path, right? So in an ellipse, there are two axes. One axis that passes through the foci, okay, that passes through two foci. So that is known as major axis. The half of it is known as semi-major axis, okay, which is A. Okay, so this is the law. Okay, now I can see that there is less than 1 minute time left. Okay, so see you in the next class, inshallah, and we will be discussing about this deduction of mathematical expression of Kepler's law from Newton's law of gravitation. Okay, and before that, go through whatever I have discussed, and if you find any problem or